Welcome to GCSE Physics. In this video, we'll explore the complete topic of electricity, covering key concepts like current, resistance, circuits, and more. Fundamentals of electricity. In circuit diagrams, we use standard symbols to represent components. This helps everyone understand the design of an electric circuit at a glance. Electric charge is a fundamental property of matter that causes it to experience a force in an electromagnetic field. Electric current is the rate of flow of these charges. Electric current is the flow of electrical charge. The total charge transferred can be calculated with the equation Q equals I multiplied by T, where Q is charge, I is current, and T is time. Potential difference is the amount of electrical energy transferred or work done per unit of electric charge passing between 2 points in a circuit. The resistance of a wire is so much it stops the flow of electricity, measured in ohms, ohm symbol. Circuit components and diagrams. Standard circuit symbols are universal graphical pictures used in BBC bite-sized circuit symbols to represent electrical parts like the cell, lamp, and switch. They let people worldwide read and build schematics without language barriers. A single current path defines a series circuit, where electricity flows through components one after another in a single loop. Voltage division is an electronic technique that splits an input voltage into a smaller fraction using two or more components connected in series. A parallel circuit is an electrical setup with multiple branches, meaning the current divides so that parts of it flow through different paths. Investigating electrical behavior. Electric current is the flow of electrical charge. The total charge transferred can be calculated with the equation Q equals I multiplied by T, where Q is charge, I is current, and T is time. To investigate how the length of a wire affects its resistance, you measure the current and potential difference for different lengths of wire, calculate resistance using A equals VI, and plot a straight line graph. Current potential difference, IV, characteristics are graphs that show how the electric current, I, flowing through a component changes as the potential difference or voltage, V, across it changes. Thermistors and light-dependent resistors, LDRs, are special semiconductor components whose electrical resistance changes based on environmental conditions. Thermistors react to temperature, while LDRs react to light intensity. Current is the rate of flow of charge. Potential difference, or voltage, drives the current, and resistance opposes it. Ohm's law links them, I equals V divided by R. Resistors control the flow of current. A fixed resistor has a constant resistance, while a variable resistor lets you change it, affecting how much current flows. LDRs, light-dependent resistors, and thermistors are crucial variable resistors in GCSE Physics used in automatic sensing circuits. Both components have resistances that drop as their environmental conditions increase. In a series circuit, current is the same at every point. Potential differences across components add up to the total voltage supplied. Parallel circuits offer multiple paths for current. Each branch gets the full voltage, and the total current is the sum of the currents in each path. Power, energy, and safety. Electrical power is the rate at which an electric circuit transfers energy. Power, P, is measured in watts, W, where 1 watt equals 1 joule of energy transferred per second, 1 J/s. Direct current, DC, flows in one direction, like from a battery. Alternating current, AC, changes direction regularly. This is the type used in mains electricity. Domestic electricity supply features a potential difference of 230 volts at 50 Hz, utilizing an alternating current, AC, protected by core safety mechanisms including the earth wire, fuses, and circuit breakers. In the UK, mains electricity is 230 volts and 50 Hz. It uses a three-wire system, live, neutral, and earth, each serving an important safety role. Power is the rate at which energy is transferred. It's calculated using P equals V times I, or P equals I squared times R. The energy transferred by an appliance is found using E equals P times T. For example, a 2 kilowatts kettle used for 5 minutes transfers 600,000 joules. The national grid carries electricity from power stations to homes. Step-up transformers increase voltage to reduce energy loss, and step-down transformers reduce it for safe use in homes. Static electricity is caused by the buildup of charges due to friction. When certain materials rub together, Electrons transfer and leave a net charge. An electric field surrounds a charged object. Field lines show the direction a positive test charge would move. The closer the lines, the stronger the field. Review and exam preparation. Key equations and mathematical skills in physics mean the core formulas used to describe natural laws and the foundational calculation abilities required to solve, manipulate, and interpret them. Voltage and current are two different things. Voltage is the electrical push or energy per charge, while current is the actual flow of those charges. People often get confused because high voltage does not automatically mean high current, and voltage is not used up like a fuel. To recap, we've covered the full electricity topic, understanding how electric current works, how energy is transferred, and how circuits are built and analyzed. Thanks for watching. Be sure to review regularly and practice with exam-style questions to consolidate your understanding.